In this video, we will discuss what is ORM, or Object Relational Mapping. It's important to recognize that ORM is a separate Doctrine project. It has its own namespace, which is Doctrine/ORM, and it utilizes DBAL, or Database Access Layer, to access the database through the underlying PHP database extension which is selected. Essentially, what Doctrine ORM does is it allows you to translate between an object in your application, which is referred to as an entity, and an actual database table. The beauty of this arrangement is that your application only needs to work with the entity and does not have to have an awareness of the underlying database extension, nor its specific commands or SQL dialect. One of the main features of ORM is its relational mapping capabilities. It supports the major mapping types, including one-to-one, one-to-many, many-to-one, and many-to-many. Doctrine has its own unique terminology for parent and child. The parent is referred to as the owning side, and the child is referred to as the inverse side. When you have a bidirectional relationship, you can have both owning and inverse, whereas a unidirectional relationship, you only need to specify the relationship on one entity and not on the other. Notice that Doctrine will only check the parent or owning side if changes are to be made. So as an example, we are looking at an entity called customer. Customer is represented by a file called customer.php, which is in the application entity namespace, which matches the directory structure. Moving down, you'll notice there's a one-to-one relationship between customer and profile. With purchases, there's a one-to-many relationship, where there's one customer with many purchases. Notice for products, there's a many-to-many relationship, where there are many customers and many products. Doctrine ORM has an extensive query capability. There are two primary methodologies. One is using what's called the Doctrine query language. The other is using a tool called the Query Builder. We are looking at an example file, ORM queries dql.php. You'll notice on line 16 that we specify an SQL query using a string. On line 18, you'll notice that the parameter for the last name is in the form of what we call a placeholder. On line 19, we use the entity manager to create a query using the SQL string. We can then assign the parameter to the placeholder, in this case, Richards. On line 22, we will echo the query, and on line 25, we will retrieve the result. In this example, the result will be an array of prospect entities, which we can then iterate through in a for-each loop using a specialized method we've developed in the prospect service, which displays prospect information. Let's now go ahead and run the sample program. First of all, this is the query that's generated by Doctrine. Notice it uses the safety precaution of identifying each field specifically rather than using the generic star. The reason for this is to help protect against SQL injection. You'll also notice that the last name field is represented using a placeholder. This value is then supplied during the execution stage. We now see the results from prospects where the last name is Richards. Our second example is ORM queries querybuilder.php. The logic is identical, however, you'll notice the difference on lines 16 through 20. On line 16, we use the entity manager to get a query builder instance. On line 17, we use this instance to build the query just as the previous example, however, we're using an object-oriented approach. The advantage to this is that you can specify the components of the SQL query in any order, and furthermore, it creates an object which could be tested independently using unit testing. Notice that the query builder also supports named parameters. In this case, there's a method called setParameter, which allows us to assign a value of Richards to last name. Then, as before, we retrieve the SQL itself. We then retrieve the result directly by running getQuery getResult. Having a look at the output, you can see from the output that it's identical to the example we just showed using the Doctrine query language. Doctrine ORM also supports what are referred to as cascade operations. These are options which are added to the column annotation. The options include cascade equals persist, remove, merge, detach, refresh, and all. What happens in this case is that Doctrine establishes constraints on relationships between tables so that if a parent entity is removed, you can set up cascade equals remove so that the child entities are removed at the same time. Note, however, that the cascade operations are performed entirely in memory, and this increases what is called the unit of work, which is an object internally managed by the entity manager, which contains operations which will be executed upon a flush operation. So as an example, let's say we have a customer, Leonard Nimoy, and this customer has several purchases. If we look at the database, you'll notice that the customer ID is 100. If we look at the purchases table, you'll notice that there are 2 purchases at the end of the list where the customer ID is set to 100. Let's now go back to customer.php, which is in the application entity namespace. If we look under purchases, you'll notice in the one-to-many relationship specification that there's an option cascade equals persist and also remove. Thus, if we remove this customer, Doctrine will automatically remove the purchases. Let's go ahead and perform this operation. If we now go back to the database and do a refresh, you'll notice that the purchases assigned to customer ID 100 have been removed from the database. Doctrine ORM also supports an event subsystem. As an entity goes through its life cycle, various things can happen to this entity. For example, initially, you would use the entity manager to persist the entity. The entity may then later be updated, and ultimately the entity may end up being removed. This is referred to as the entity lifecycle. As the various operations occur, Doctrine will internally trigger events, which you can tap into. This allows you to define what are called listeners or subscribers, which can implement the various methods including pre-persist, pre-update, pre-remove, which occur before these major operations, or post-persist, update, or remove, which occur after these respective operations. We are now looking at prospects.php, which represents the prospects entity under the application entity namespace. You'll notice there's an annotation has lifecycle callbacks. The lifecycle callbacks are then specified by using the appropriate annotations. In this example, we are implementing pre-update. So before the update operation occurs, in this example, the last updated field will be set to the current date and time. Another way to utilize the event subsystem is to set up what are called entity listeners. In this case, the entity annotation for prospects indicates that there's a listener called prospects listener. The class for this can be found in the application listeners namespace. You'll notice also in this example we've identified pre-update as the lifecycle event we wish to tap into, and in this example we are updating the status. This example, ORM events.php, demonstrates the use of lifecycle callbacks. We find a random prospects entity. We then check to see if the last updated field has been set. We then show before and after the persist operation. This way we can verify whether or not the listener was effective. Running the example, you'll notice that initially the updated field was not set. However, following the update, the field was now updated with the current date and time. Here's another example, ORM entity events listener.php, where we are using the prospects listener just now identified. Notice that we need to register the listener with the entity manager by getting the configuration, setting up a resolver, and registering the new listener. We can then do the same thing as previously by making a change and showing the status before and after. As you may recall, in the prospects listener, we are updating the status field. Running this example, you'll notice that the status field for this particular prospect was not set. However, following the update, the status field now says update 01. Finally, ORM also supports transactions. These are automatically supported by the entity manager itself. However, you can also explicitly use transactions by getting the connection from the entity manager, then issuing begin transaction, commit, or rollback.